All right. So, hello and welcome everyone. I hope I'm audible to all of you. Please let me know if I'm audible to all of you. All right. So, wonderful. Right. So, how are you doing? I hope you have all had a wonderful class. So, if you're new to this particular channel, I would like to say that we are basically discussing about the JEE mains topics, and especially we are taking each and every topic every day, and we are discussing the top important previous year question on that particular topic, right? And before this class, we already had a chemistry class, right, on atomic structure. I hope you all had enjoyed that particular class, right? Please let me know what did you like the most. Okay, so I hope you had a wonderful time discussing about the atomic structure, right? All right, so yeah, so welcome back to this particular session, and today's our topic is going to be on that session of area under the curve, right? So we are basically discussing the most important previous year question, and today our topic is area under the curve. Now, before starting the area under the curve, I would like to tell you that before starting this particular topic, you have to have the understanding of the definite integral. Without finishing the definite integral, you cannot come and solve the problems with us, right? So I would request all of you to please go through the videos of the definite integral and the indefinite integral that I have already taken up on this particular platform itself, right? So if you go and watch those particular session, it will be very helpful to all of you. Okay. All right. So with this, let's get started. And the very first thing before we start, we have to. So before we start, I would like to tell you these things that before you start for any particular topic, what all things are very important to understand and necessary to basically start up for this particular session is that before you are starting the session, you have to have a good understanding and a hold of your NCRT, right? So please make sure that you complete the NCRT revision, and please make short notes. Please make short notes, right? These short notes are going to be very, very useful for your quick revision. And after you're done with the NCRT questions, also you have to basically finish up the NCRT exemplars. NCRT exemplars, right? So please make sure that you complete these particular topics. Okay, NCRT exemplar questions as well as the NCRT problems, right? So once you're done with this particular topic, then you can start watching this previous year question solving sessions. Okay. So with this, let's get started on this previous year question session, and our topic is going to be area under the curve. Now, if you look at this chapter, this is basically in the chapter of applications of integrals, right? Because you know that integrals, it's a more of like application based on the theory of integral, right? So you are going to use that particular part, and similarly in the NCRT, in application of integral, the differential equation are also present, right? So make sure that you cover both the parts together, right? And in the upcoming session, I will take up the differential equation, and that will mark the ending of the integral calculus. Okay. And if you are still new to this particular channel, I would request all of you to please subscribe to the particular channel, because we are basically discussing this particular topic, which are very, very useful for the upcoming JEE mains paper, right? So with this note, let's get started. So today our topic is going to discuss about the area under the curve. Now I will be specifically discussing how to solve the algebraic area and what is the difference between geometric area, right? Now in this chapter of area under the curve, we are specifically going to find out the geometric area, right? Now algebraic area and geometric area are different in sense that algebraic area is an area with a sign. For example, like I would like to tell this example very much frequently in my classes is that, for example, let us say I have a graph of function something like this, right? And it is bounded by the domain a to b, or maybe I am interested to find the area under the curve in between a to b. Now, whenever I talk about area, the first thing and foremost thing that comes to your mind is basically to calculate the definite integral. But unfortunately, if you calculate definite integral, you will end up getting the algebraic area. For example, let us say this particular curve is y is equal to f of x, right? And if I integrate this curve, if I integrate this y function with respect to dx, and if I do it definite integral, and let us say this part of the area is given as capital A1, this part of the area is given as A2, and this particular part of the area is given as A3. Now, when you calculate definite integral, the solution is going to be A1 minus A2 plus of A3, right? Because when you calculate definite integral, this y part which is below the x-axis is going to be negative, and therefore the integral expression while you calculate definite integral is going to come out as negative, right? Now, once you get this is going to be the value of the definite integral, right? But unfortunately, in the chapter of area and the curve, we are going to report the geometric area. So the definite integral gives you the answer of the algebraic area, right? So this is basically the algebraic area. And in the chapter of area under the curve, so whenever we talk about area under the curve, right, we basically mean the geometric area. All right, so let me write this clearly. So area under the curve, we specifically mean the geometric area, right? So what do you mean by geometric area? Is basically summing up all the numerical area, right? Summing up all the numerical area. So therefore, this particular area is going to be A to B. Now, instead of y, I'll just put a mod of y to make it positive, because ultimately I need the magnitude of the area, right? I'm not interested in the sign of the area, right? I'm not interested in the algebraic area. I'm interested only in the geometric part of the area, right? So that is going to be mod of y dx, and therefore your area will be equal to sum of all the individual area, right? Now this is what you have to find out in this particular chapter of area under the curve. Now this is all we have done in the chapter of definite integral. So please make sure that you understand this very basic difference between definite integral and area under the curve. Now I know most of the students doesn't know this particular difference. They think that whenever they calculate area under the curve, that is basically simple a definite integral. Please make sure that there is a very big difference whenever I'm calculating y dx and when I'm calculating mod of y dx, right? There is a big difference between these two particular things, right? So make sure that you understand this particular difference and you act accordingly, right? So with this part, let's get started, and our topic is to discuss the concept as well as we are going to discuss the previous year question, both MCQ and numerical time, and also we are going to predict how the JEE advanced questions are being asked up, right? And also with that, we are going to do some paper analysis, and with that, we're going to complete and wrap up the session, right? So let's get started. And if you look at the weightage of this particular chapter, this weightage is something around 1 or 2 questions, okay? So it is not that very high priority, but it is very interesting and easy chapter. It's a very high scoring chapter. So definitely one question will come and you are going to solve that question and you're definitely going to get the +4 marks. All right. So with this part, let's get started. So here is a very first question on your screen. Now I would request all of you to please have it a look and give it a try. Please have a look and give it a try, right? So if you look at the problem over here, this problem is talking about that we have a curve. Now let me write down the curves. So we have the curve mod of x is basically given as 1 minus x square. Now before you start for this particular chapter, some particular small things are very interesting that you need to understand. Is that one of the topic is curve sketching. Before you discuss about the area under the curve, it is very important to know how to plot the curve, because sometimes the question is very simple if you are able to draw and visualize a curve in that. Okay, so in that case, curve sketching is an important topic, right? So here you have the mod of y is equal to 1 minus x square. So let us try to first plot the graph of y is equal to 1 minus x square, right? So y is equal to 1 minus x square is just simply a graph of a parabola, right? With roots as 0 and 1, and it will be opening downward, right? Now what you will see that it is a mod of it, right? So I'm putting a mod on the y part, right? So when I'm putting mod of y, that is basically means that basically implies that the values of y, whatever you are getting, the values of the y is positive. The values of the y is positive, right? So let us try to understand very simple way is that if you are taking a simple value 1 by 2, it will have like, if your value is 1 by 2, that is basically mod of y is equal to 1 by 2. Now let us say that I put 1 by 2 as x, so therefore I will get 3 by 4 over here, right? If I put x is equal to 1 by 2, then y mod of y will be equal to 3 by 4, right? Mod of y will be coming out as 3 by 4, right? Now Now once you are able to do this, then y is basically equal to 3 by 4, or it is also equal to minus of 3 by 4, right? So you have two values. You will have two values of y, right? So that is one y is positive, one y is negative. So it is just reflection about the x-axis. Now whenever the curve sketching is given in terms of, now if in place of this y is equal to 1 minus mod of x squared, then you have to just reflect the curve about the y-axis. That is a simple sketching that you must understand in order to solve this particular problem. So if I implement that particular thing over here, so if I just simply implement that particular function over here, right? So therefore the graph of the function is going to look like, right? So in this case, the curve of the function is going to simply look like, as you can see over here, the first of all, for this particular region, now let me be very precise over here. Okay, so 1 minus, if you take, so this is going to be basically 1 minus x into 1 plus x, right? So it will have both roots 1 and minus of 1, right? And it is going to be opening downward, right? It is going to open downward. So if you put 0, it is going to be 1, something over here. So something like this, right? Something like this. It's a parabola opening downward, right? Now since mod of y is provided, so I will just reflect the curve about the x-axis, right? So I will just reflect the curve about the x-axis, and therefore this curve is going to be very symmetric. This curve is going to be very symmetric like this. And we have the second equation, which is x square plus y square is equal to 1, is just nothing but an equation of a circle with the radius equal to 1 and the center equal to 0, 0. So which is something like this, right? Now once I am able to predict what is the graph of the function, now it is said that the area enclosed in between these two graphs. So this is our curve 2, the circle is our curve 2, and this is our curve 1, right? So the area enclosed in between these two curves is basically this particular area. The area enclosed in between these two curves is basically this particular part of the area, right? So over here I am shading this area. So since you can see the area that I have to find out is very symmetric about the 4 quadrant, right? So if I find out only this part of the area and I just multiply it with 4, then I'm going to get the entire area. That's our motive, right? And it is said that the area enclosed in between these two curves is given by alpha, right? And then it is said that, our value of our value of 9 alpha our value of 9 alpha is equals to beta pi plus gamma, is equals to beta pi plus gamma, where beta and gamma are the integer values. So we have to basically find the difference of the beta minus gamma. So let us try to find this particular area out. So therefore our required area is basically 4 times the integral 0 to 1, and I will be first of all subtracting the circle, the upper curve minus the lower curve, right? That is a way you to solve it, right? So it is the area of the circle. So what I can do is the area of the circle in the first quadrant, so that I can directly write it out. Instead of doing the integral, I can directly write the area of the circle in the first quadrant. So area of the circle is basically pi r square, and divided by 4 will give the in the first quadrant, okay, one of the quadrant of the area, minus this particular area of the curve, that is basically 0 to 1 integration, and that I will do it as 1 minus x square dx, right? And from there, if I subtract this particular value, then I am going to get the required area, right? So that is going to be equal to 4 into pi upon 4 minus now this particular integral is going to be x minus x cube by 3 within the limit 0 to 1, right? And therefore if you solve this result, therefore your area, which is given as alpha, is going to come out as pi minus 8 upon 3. And if you compare this result, this is basically given as beta pi minus gamma, right? Now it is said that 9 alpha is given as this, right? So let us do it in the next step. It is said that 9 alpha is equal to, so 9 times of alpha is equals to 9 times of pi minus this is going to 3 into 24, right? 3 into 8, that is 24. So therefore this is given as beta pi plus gamma. So from here your value of beta is equal to 9 and gamma is equal to 24 minus 24, right? So from this way you can find out the difference of beta minus gamma is equals to 33. For mod of that is going to be equal to 33, right? So therefore the answer to this particular problem is going to be option number C, and that is basically 33, as we can see in this particular problem, right? I hope this is clear to all of you. Right, very simple problem. Just you have to find out the particular graph of the function. Now for plotting the graph, there is a certain knowledge that you need to solve this question. Is basically some concept of curve sketching, that whenever I put mod in x or whenever I put mod in y, how to transform the function. So once you're able to do the simple graph, whenever I take a mod in y, you have to reflect the curve about the x axis, right? Because it is symmetric about the y, so therefore you have to reflect the curve about the x axis. Similarly, when I put a mod in x in the given equation of the function, so in place of, so if I have to plot for f of mod of x, right? So in this case, I'll just reflect the curve about the y axis. That's the simple idea. Okay, so once you know this particular simple idea about curve sketching, then this question is very, very simple. I hope this is clear to all of you. I hope this is clear to all of you. Please let me know this particular part is clear or not. So I'm going to a live chat. Please let me know. Right? Is this part clear to all of you? Wonderful. So, so I hope this is clear, right? So let us try to take up with the next problem. Okay. If this part is clear to all of you, let us take up the next problem. All right. So the next problem over here is on your screen. Now again, if you try to draw the graph of this function, if you try to sketch the region, then the question is again very, very simple. So please try to solve the, try to get, first of all, get the region or try to get the bound of the region, and then you try to solve for the area. Right. So please proceed for this question. Please try to proceed with this question. All right. Please try to proceed with this question. The question is fairly simple. Okay. All right. So let us try to see how we basically proceed with this question, right? So very first thing that you need to do is basically try to plot the region. So let us try to plot the region over here. So very first thingly, so we have the given region which is bounded by x square plus of 3 is greater than x square plus 3 is greater than or equal to 2y, right? And then y plus mod of x is less than or equal to 3, and similarly y is greater than, and similarly y is greater than or equal to x mod of x minus 1, and therefore we have the area of this particular region given as A. So we have to ultimately find the area of the region. So first of all, let us try to see how we plot the region, because we have three given inequalities, and from these three given inequalities we have to basically try to plot the graph and then we calculate the area. So let us see how we can do that. So very first I am taking this particular part of the inequality, right? Because it is very simple, it is just going to be a linear curve, right? So let us try to plot it. So all right, so I think I can adjust in between this particular region. Right. So here x, y over here. So let us first of all try to plot this. Then now if I take this curve y is equal to x minus 1 mod of it. So I'll just have to reflect about this x. So it is curve is going to be simply like 1 over here, and the curve is going to be like modulus function of like this, right? That's the first function. The second function is y plus mod of x is less than equal to 3. So let us first of all plot x plus y less than or equal to 3, right? So x plus y less than or equal to 3 is going to be something like this over here. It's going to be 3, and then it is going to be 3 over here again, and like this particular curve. And then since I have mod of x, I will just reflect the curve over the y axis, right? So it is going to be simply like this, right? I hope this is clear. Now, the first inequality is given as y is less than x square plus 3 by 2. Now, this is going to be a equation of a parabola. This is going to be equation of parabola. So, at x equals to 0, x equal to 0, the y is going to be equal to 3 by 2. Y is going to be equal to 3 by 2. So, from here, at x equal to 0, this is basically 1. So, 3 by 2 is greater than 1, right? So, it is going to be something like this, and it is going to be some upward opening, and also it is going to be something like this. All right. I hope this is clear, right? Now, if you look at this particular region, so this is basically y is equal to x minus 1. This particular curve is y plus x is equal to 3, and this is curve is basically x square plus 3 is equal to y, right? So we have this particular plots of the regions, right? And once we have this region, we have to basically find out the ultimate area is this particular area. So let us shade it in some different color. So this is what the area we are basically required to find out for. So this is the area that we need to find out over here. All right. So this is the area that we need to find it out. Right. Is this part clear to all of you? Is this part clear to all of you? All right. So first of all, let us try to find the bound or the points by which it is bounded, right? So if you calculate these points, this point, the first of all, let us calculate this particular point. This is basically 1 comma 0. Let us call this A, and this is basically B. In the B point, you will find it as 2 comma 1. Similarly, let us call this C. This is basically 1 comma 2, and this is called this particular point. Let us call this as D, and this is basically given as minus 1 comma 2, right? So we have this as the bounds of the region, right? So we have the region, and we have to basically find the required area. So our required area which is given as A is basically equals to, so how can we simply find out this particular area is that if you try to find out, first of all, if you try to find out this area of this, so just ignore the diagram. Actually something like this minus 1 comma 1 will be something over here because I have kept it till here. Okay, so this is going to be like area of this rectangle minus area of this particular parabola region. So if I subtract that, then I'm going to simply get the region, right? So let us call this some point as E, right? Therefore the area is basically rectangular area of the rectangle, area of rectangle AB, D, AB, D and E, right? Minus the region, the area of the region DEC. So minus area of that particular region that is bounded by that straight line and the parabola. If you subtract that, then we get the required area of the region, right? So from here, if you try to do the integral, so our area is going to be, so this area of the rectangle is going to be simply equal to 4. If you can see here, it is basically 1 unit, and this is basically 4 unit over here, right? This particular is 4. Right. So this is going to be area of rectangle is going to be 4 minus this particular area. Now this particular area is again very symmetric because I know that this particular line is again mod of x is there, right? So it is symmetric. So if I just find out only this part of the area and then multiply to that, also will work fine, right? So 2 times the integral 0 to 1, and then I have the curve as 3 minus x minus the parabola is basically given as x square plus 3 by 2 and this is going to be we have to integrate in order to get to the area. So therefore our area from here is going to come out as 4 minus 2 times of integral within the bound 0 to 1, and so let us try to integrate it and then put the limit. So it is very simple. It is just an algebraic integral. So it is going to be equal to 3x minus x square by 2 minus x cube by 6 minus 3 by 2x, right? And within the bound 0 to 1. And therefore, if you put the value over here, that is 4 minus 2 times of 3 minus 1 by 2 minus 1 by 6 minus 3 by 2 right? That is when we put the limit, and therefore this particular area is going to come out simply as 7 upon 3. This particular area is going to simplify and come out as 7 by 3. So the finding the area is very simple. Once you are able to find the region and how to find the region, that's the most important part. Once you are able to find out the region, the question is very simple in terms of finding the integral area. All right, is this clear to all of you? So therefore we got the value of A as 7 upon 3, and once we calculate for the, we have to basically calculate for the value of 6 times of A. So 6 times of A is going to be equal to 14. So therefore, answer to this particular problem is going to be option number A. So answer to this particular problem is going to be option number A over here. I hope this is clear to all of you. I hope this is clear to all of you. Please let me know if this particular part is clear or not. Just let me know yes or no. Is this part clear or not? Right. I'm expecting this part is very simple and clear to all of you, right? Right, because the chapter is very simple. Once you are able to plot the region, that is basically required in the problem, then the finding the area is just a matter of understanding of how to use the integral expression, right? So that is very well known to all of you, and I make sure that you cover the NCERT, because in NCERT if you solve the problems, this concept will be very simple and clear. Okay, I hope this is clear to all of you, right? So please make sure that you practice the NCERT questions, because in NCERT the questions are really good, and once you practice those questions, once you get a hold of the concept, then the questions, then you can solve any types of questions. Okay, So that's the main motive for behind me asking you to solve the NCERT as well as the NCERT exemplar. And many times if you look at the JEE Mains problem, you will see there are a lot of repetitions that has been occurred from that particular part. Okay. So with this, I hope this is clear to all of you. I hope you are also getting the answer as option number A, right? So please let me know if this particular part is clear or not. Let me know if this part is clear or not, right? Okay, wonderful. Now, if this is clear, so we can proceed with the next problem. The next problem, again, we have to basically find out the region. Now, these types of problems are very, very simple. Once you are able to find out the region, the finding of the area is much, much simple in terms of the just solving the derivative. Okay, just solving the integral expression, the definite integral expression, right? So if we look at this question over here, let us try to understand how we plot the graph. So the first equation is given as x into 1 plus y square is equal to 1. So therefore I can plot x is equal to 1 upon 1 plus a y square. And similarly the next part is given as y square is equal to 2x, and the next part is given as y square is equal to 2x, right? So let us try to find out how we can plot the function, right? Now this particular curve is very, very simple to plot, right? I hope you know how to plot this curve, right? So we are going to simply use the calculus, but since now if you look at, interesting part is that if you have the curve is y is equal to 1 plus x squared, the curve is going to look like, so at x is equal to 0, the curve would have maxima, okay, something like this, okay. So similarly, if I interchange the x with y, then the curve is going to just shift in the x and y axis, so it is going to look like this, right? That's the only difference, okay. So that's the only difference that you need to do it over here, right? And how I'm getting the curve is again very interesting. It is basically, if you just apply the concept on drawing the graph and finding out the, like, for curve sketching there will be a ultimate course on it, okay. So you can watch your, you can try to study it from any of the like standard textbooks, okay. So there is a dedicated particular textbook especially on the topic of curve sketching, okay. You can find out the textbook. There are a lot of textbooks in the market out there, okay. So you can follow the standard textbook. It is wonderful and fine. But when I say that if you have to plot any curve, the most important thing is to first of all find out the values at 0, positive infinity and negative infinity. Now since infinity is not a number, it's a concept, so we have to basically find the limit at infinity and minus infinity, and then we have to find the value at x equal to 0. If we are not able to find the value at x equal to 0, we have to find the limit at x equal to 0. So from that you get the initial sketch, okay. Then we have to basically perform the maxima minima analysis and the increasing decreasing analysis. Once you do that, once you plot the sign scheme of f dash of x, once you plot the sign scheme of f double dash of x, you are going to find out that in which region it is increasing, in which region it is decreasing, and in which region it is having concave up and which region having concave down. So with those analysis you can always try to plot a rough sketch of the graph, right? So that is basically simple, and I am leaving that part up to you. So the curve of x is equal to 1 plus y square by 2, y square sorry, 1 by y square plus 1 is going to simply look like this, okay. It is something like this, okay, asymptotic at the infinity, okay, plus and minus infinity, right? Now, and if you plot the second curve, that is y square is equal to 2x, is going to look like a simple parabola like this, right? So therefore we have to basically, let me write this, so this is the curve which is relating to x is equal to 1 upon y square plus 1, and this is the curve which is relating to y square is equal to 2x, right? So ultimately we have to find out this particular area. So ultimately we have to find out this particular area. Now again you can see there is a symmetricity in the problem. Now whenever in the portions of area under the integral, whenever you see a symmetricity, whenever there is a symmetricity involved, it is always advisable to find one part and then multiply by 2. That's the best thing, right? So instead of finding the entire part, but what you can do over here, instead of solving in the limit integral in dx, I would say try to solve it in dy, right? So if you do the same thing, then the area will be equal to, so the bound of the area, so this is, if you can find it out, this is going to be minus of 1 and this point is going to be plus of 1. So it is going to be minus 1 to 1, like I am integrating in y, okay. So minus 1 to 1, and the value of the upper function is going to be 1 upon 1 by y square minus the lower function is going to be y square by 2, right? And then integrating with respect to dy, right? So I just simply integrate. Now in solving dy it is simpler, because if you try to solve it in x, then the question is very difficult, because you have to again convert that y to x and then you have to solve for it. Instead, why not solve for it in y only? Okay, so that will give you the quick result. So in this case, this integral is basically tan inverse of y minus y cube by 6, and we just put the limit, that is minus 1 to 1. that is minus 1 to 1. So ultimately your answer of this particular area, is going to be equal to pi by 2 minus of 1 upon 3, pi by 2 minus of 1 upon 3. All right. So is this part clear to all of you? So since it is an even function, again I can change the integral from 0 to 1 and multiply it with twice, right? So that is a step that you already know it, and how to solve for it is very well known to all of you, right? Because you have already finished the chapter of definite integral. So in the definite integral, you must have studied about this, all those properties. So with this, you will see that option number B is going to be the correct answer from here, right? So I hope you are all getting the answer as option number B. I hope you are all of you are getting the answer as option number B, right? Is this part clear to all of you? Is this part clear to all of you? Please let me know in the live chat. Is this part clear to all of you? I'm expecting this part is clear to all of you, right? So let's proceed with the next problem then. So the next problem is, again we have to basically try to find out the area under the region. Now you can see there is a very symmetricity in the problem involved, right? So once you're able to plot the sketch of the region, and then you have to just, matter of fact, you have just have to apply the concept of the finding out the area by just doing the definite integral, right? So that is very well known to you, and if you practice those solved examples from NCERT textbook, this concept is going to be really simple and clear to all of you. Okay, so let us try to take up the next problem. So again, if I try to draw the region, the first curve is basically is given as y is less than 2 times of mod of x plus of 1. So it is going to be simple straight line. So let us try to plot that straight line, right? So at x equal to 0, the value of y is basically 1, and at y is equal to 0, the value of x is equal to, so I'm just putting 2x plus 1, and that particular value of y is going to come out as minus of 1 by 2, right? So it is going to be curved like this. And since if I have the curve, but we should not draw it like this way, right? That's the main mistake that people do. We should draw the, first of all, we should draw the part of the curve which is basically greater than, which is basically lying in the curve part of the x, which is basically greater than 0, right? So let us try to plot. This is going to be something like this, right? And since mod of x is involved, so I will just repeat this over here, and it is said that y is less than this part, right? So y part is less than, so therefore this 0 comma 0 will satisfy the equation. So this is going to be this particular region, right? This particular region which is talking about. And the second region, if you would like to plot it over here, it is talking about y is less than x square plus 1, which is a parabola, like this. Now you know that parabola, in between 0 to 1, it is slower increasing, and after 1 it is increasing larger, right? Okay, so like this over here. So sorry, this is going to be 2, this is going to be minus of 2, right? The point of intersections where they are intersecting, right? Right, fine. So now from here, and then mod of x is also less than 3. So mod of x is less than 3, that basically means, so mod of 3x is less than 3, that is basically means this straight line. Okay, means a straight line. I will just plot a straight line. Over here. So I hope you can understand this minus 3 point over here. So therefore this will give me the bound of my region. So I hope if you are able to plot the region, once you are able to plot the region, the question is very simple. Okay, once you are able to plot the region, the question is very simple. So once you're able to plot the region, the area is going to be simply as, so area is going to come out as, now since again it is symmetric about the y-axis, I will just take the positive part of the x and then multiply with 2, right? So there is 2 times of integral 0 to 2, that is the integral of the parabola, that is x square plus 1 dx, plus the integral from 2 to 3, and within that particular curve, that is 2x plus 1 dx, right? So very simple integration. So just a one liner question. So from here, if you just integrate it, the area you're going to get it as, 64 upon 3. The area you're going to get it as 64 upon 3 square units. So therefore from here, the answer to this particular problem is going to be option number B. Option number B, as simple as that. All right, so I hope this particular part is clear to all of you. Right? So now with this particular part, I think that you must have understood what I'm basically doing in this particular chapter. Once we are able to draw the region, the finding of the definite integral from that, and from that to find the area under the curve is very simple and straightforward, right? So with this, I am basically trying to understand and make you explain that the questions are very simple. Please make sure that you practice the NCERT problem. Please practice more and more questions so that the section is very simple. And I don't want you to miss out on any particular questions on this, okay? Because the topic is very simple. Once you're able to plot the graph sketching is more important in this particular chapter, okay? So make sure that you plot make sure you study the curve sketching part very nicely. Okay. Okay, curve sketching is very, very important for this particular chapter. Okay, curve sketching is very important. So once you understand the curve sketching, the questions are fairly simple. Is this clear to all of you? Right. So I have some homework problems for all of you. I have some homework problems for all of you. So this is the first homework problem. Please try to solve this homework problem and let me know the answers in the comment section. Okay. This is the first homework problem. Please take a screenshot. Please take a screenshot. And then we have this next homework problem. Right. This is a homework problem number 2. Again, very simple. Once you plot the region is very simple to plot, right? As you can see, it's a going parabola and one straight line. So then you have to basically find out the bound of the region, and then from that you have to find out the area under the curve. And this is your third homework problem. And this is the third homework problem, right? So you can see that there are no more kind of an interesting problem is there once you are able to find it out, and there is a more or less same kind of problems that has been asked in the different shift and different attempts. Okay. So with this particular idea, I want to conclude my session telling you that once you get the basic concept, once you're able to draw the curve, once you're able to find out the region, the getting the area is just a one-liner concept. Okay. Only thing that the questioner can make a difficult thing is basically they will try to give you a critical integral, but as you can see that the question what I have tried to solve it, the integrals were very, very straightforward, right? So that is what you can understand, right? The integrals are very straightforward. Don't try to over coordinate or over complex things. Okay, if you try to simplify the things and try to find the area in terms of this simpler area minus some complicated area, then the thing is very simple. Instead of doing the area as a finding out the entire integral, right? So doing that particular part will come only from practice. So more the question you practice, the more better you're going to become at it. Okay. So I have given this homework problems just for your practice. Please solve this question and let me know the solutions in the comment section. Okay. So I am looking forward for your answers. And with this, let us end our session over here, and thank you.